This video was created to help provide a better understanding of the breathability tests performed according to NFPA 1971. These tests are used to evaluate how well firefighter gear is at allowing air and moisture to move through the composite and therefore cool the wearer. When talking about the importance of breathability, we can start by looking at the data reported by the National Fire Protection Association from 2019. Over half of the deaths in 2019 were related to overexertion, stress, or other medical conditions. One of those deaths was directly related to heat stroke, and an additional 24 of those deaths were cardiac deaths or stroke-related. The work that a firefighter has to endure is strenuous, and we need to make sure the PPE is adding as little as possible to that strain. This is why we measure breathability. When a composite is more breathable, it means that it allows the air and moisture from inside the garment to transfer through the materials and outside of the garment, while protecting the wearer from outside contaminants. In order to achieve higher breathability, generally the composites are lightweight. By being lightweight, the materials block less of the air and moisture from passing through. Also, by being lightweight, the overall strain on the person wearing the PPE is lower. Composites are built to protect against many different hazards, from thermal protection to abrasion resistance. This is why there are multiple layers used. Generally, the composite consists of an outer shell, a moisture barrier, and a thermal barrier. By having these multiple layers, thermal insulation is increased. This comes from the storing of heat within each of the individual layers, but also in the air in between the layers. When testing for breathability, we use the total heat loss test, or the THL test. This test consists of two measurements that are calculated to provide the THL result. The first of those measurements is the thermal resistance. This measures the ability of a material to allow air to pass through the material in a dry condition. This measurement is like evaluating a lightweight t-shirt versus a heavyweight t-shirt in the summer. The lighter weight material will likely allow more air to pass through it, making the wearer feel cooler. The second measurement is the evaporative resistance. This measures the ability of the material to allow moisture through it. So when the person is sweating, will the material allow that moisture inside the garment to pass through it to the outside? The THL value is calculated using both of these measurements. As mentioned in the previous slide, THL testing consists of two separate tests which provide results that are calculated to determine the THL breathability result. The first test is the thermal resistance test, or what is referred to as the dry test. This test is performed by placing the composite so that the inner layer, or thermal barrier, is on the plate. That plate is intended to represent the wearer's skin. Then the moisture barrier is on top of that, with the outer layer consisting of the outer shell. The plate is set to a temperature of 35 degrees Celsius or 95 degrees Fahrenheit. The air within the chamber and above the composite is set to a cooler temperature of 25 degrees Celsius or 77 degrees Fahrenheit. As the warmer air rises and tries to penetrate the composite, the plate will either cool if the composite is breathable, or it will remain warm if the composite is not breathable. Meaning this is a measure of the ability of the air to go through the composite. The measurement taken is determined by the amount of power required to maintain the plate temperature at 35 degrees. The second test is called the evaporative resistance test, or the wet test. This test is performed so that the composite is placed on the test plate in the same manner that it was placed during the dry test. In this test, the plate has a membrane coating that is used to contain and evenly spread the water that is pumped onto the plate. This water and film create a surface that is meant to mimic sweating skin. The temperatures are set to the same degrees as what was done in the dry test. As the water begins to heat and evaporate, it will try to pass through the composite in order to cool the plate. Some of the moisture will condense and fall back to the plate to begin the process of evaporation again. The result is measured by calculating the amount of energy that is necessary to keep the plate at the same temperature. Similar to the THL test, there is also another breathability test called the evaporative resistance test, or RET. The results are not comparable to THL as they offer a different value that can be used when comparing composite performance. It consists of a wet test only, with temperatures being equal on the plate and in the air above it. These conditions are what they call isothermal conditions. This means that during the test, there is no natural tendency for the heated air below to rise into the cooler air above. In the RET test, we are measuring how much the composite prevents the wearer from cooling through evaporation of the water. Since the plate and the air above the composite are at equilibrium, is the composite going to interfere with that equilibrium? In summary, the THL and RET tests are ways to measure composite breathability so that one composite can be compared to another. The test conditions and breathability measurement should not be used to determine real-life breathability of a finished garment. The testing performed and the samples tested are standardized, which is very unlike real conditions. The two breathability tests outlined in this video are different and provide unique ways of measuring how well a composite would allow for the wearer to cool. One method is not better than the other, and therefore when choosing a composite, having both values can add information about that composite's performance. Thank you for your attention. We hope you found the information in this video valuable. Please feel free to contact your UL testing expert if you have additional questions.